So what is this vulnerability? The YAML Linux security module controls the ptrace system call, which allows one process to inspect and modify another process memory. In the default Ubuntu installation, the kernel YAML ptrace scope parameter is set to 0. This means any process running under a user ID can attach to read from and write to any other process with the same user ID. For example, if an attacker compromises a low-privilege web application, they can use ptrace to spy on your SSH session and steal password directly from memory without needing root access. This violates the principle of least privilege and breaks the process isolation. Using the kernel hardening checker tool, here's what our scan revealed. The output clearly shows ptrace scope equals 0, which is completely unrestricted. The scanner flagged this as a fail because any process can trace any other same UID process. This vulnerability is classified under CWE 284, improper access control with a CVS score of 6.5. The risk had confidentiality impact. An attacker can read SSH credential, browser cookies, and encryption keys directly from the memory. The mitigation is straightforward but must be done correctly. We need to change ptrace scope from 0 to 3, the most restrictive setting. Apply the change immediately using this command. Setting it to 3 completely disable ptrace attachment for the all process, even root cannot trace other processes. After mitigation, we rerun the kernel hardening checker. Now the scanner shows pass instead of fail. The value is confirmed as 3. Any ptrace attachment attempt now returns operation not permitted. Disclose a major information disclosure vector. An attacker who compromises a low-privilege process can no longer spy on the SSH session, browsers, or extract credentials from memory. Vulnerability 1, YAML ptrace scope, has been successfully mitigated.
Good day, Madam Hazlina and everyone. My name is Noba Trisha, and I will be demonstrating the scanning, hardening, and verification process for vulnerability 2 in secure SSH configuration. As you can see here, this is our pre-scan baseline audit conducted via Linus. The tools thoroughly analyze our system configuration files under SS selection is flagged that our person is wanting a warning, open SSH option, permit root login suggestion. This configuration floor leave the absolute super user root account open to the network interface and presenting a critical attack vector for automatic brute force attack. Okay, next, to mitigate this the high severity risk, we must enforce the principle of least privilege. I will now open the um, primary configuration file using command sudo nano etc/ssh/sshd config. Inside the text editor, I'm navigating to the authentication policy. I will manually modify the permit root login, directly changing the active blue from insecure yes to hardening profile of no. Now that the configuration script is securely updated, I must force the system to parse these new rules and apply them to all active network socket by restarting the daemon using sudo systemctl restart SSH. Okay, next, with the service successfully reinitiate, the vulnerability is patched to verify the remediation and ensure our system defense metric have progressed. We trigger our post hardening audit using Linus. When the verification scan reach completion, we observe two critical changes. First, under the SSH module, Okay, here permit root login. Warning suggest has been completely eliminated. Confirm that remote root login are now actively rejected by the firewall and daemon layer. This successfully concludes our demonstration, providing quantified reduction server next. Thank you.
Assalamualaikum and hi, my name is Nur Alisha Amira and I'll be presenting Vulnerability 3, which is insecure sudo URS directory permissions and how we can harden it. The sudo URS directory is a critical system location that controls which users have permission to execute commands with elevated privileges using the sudo command. If this directory has improper permissions, unprivileged users can read sudo configuration files, discover privilege rules, and potentially modify them to grant themselves root access. So let me start by running a security scan using Linux to identify vulnerabilities on this Ubuntu system. I run the command sudo Linux audit system to find the vulnerabilities. And now looking at the scan results, I can see Linux has identified 2 warnings. The key one for us is related to sudo URS directory permissions. Let me check the specific permissions on the sudo URS directory. This command is to show you the permissions level. As you can see, the etc/sudo urs.d directory currently has permissions of drwsr-sr-x 755. This means owner can read, write, and execute, but group and others can also read and execute. This is the problem. This is insecure because unprivileged users can read the sudo URS files and understand the privilege structure of the system. They could potentially discover how to escalate their privileges. The file also has permissions of rw-r-r-644, which is also word readable. For your information, the CVSS score for this vulnerability is 6.2, which is medium. It is classified under CWE 276, which is incorrect default permissions, and also CWE 269, which is improper privilege management. The fix is simple. We restrict the sudo URS directory to allow access only to the root user. First, I will change the sudo URS directory permissions to 750, which means only the owner can access it. So for the 7, owner has read, write, and execute. 5, group can execute but not read. 0, others have no access. Now let me harden the main sudo URS configuration file to be even more restrictive. I ran the sudo chmod 440/etc/sudo ers. Now let me verify that the permissions have been changed correctly. I ran the command ls-ld/etc/sudo ers.d. And now you can see the permission has changed to drws which is 700, which means only root can access. And for the sudo ers file, it has been changed to permission -r which is 440, which is only root can read. So the vulnerability has been fixed. The question is, does sudo still work after this permission changes? Let me verify that the system still functions correctly. So I ran the sudo -l. So the sudo -l command shows my user sudo privilege. User may run commands with all. This means sudo is functioning correctly. Now let me run Linux again to verify that the vulnerability has been eliminated. Looking at the results, the sudo URS directory permission warning is now gone. I think that's all for my part. Thank you.
Good morning, everyone. My name is Nurna Jafarana binti Hashim, and I will be presenting Vulnerability 4, which is Unpatched System Packages in the Ubuntu operating system. Before starting the demonstration, I would like to briefly explain this vulnerability. Unpatched system packages occur when software installed on the operating system is not updated with the latest security patches. As a result, attackers may exploit known vulnerabilities in outdated packages to gain unauthorized access, perform privilege escalations, or compromise the system. Therefore, keeping system packages updated is an important security practice. To assess whether this vulnerability exists in the Ubuntu, I used the Linux security auditing tool. First, I executed the following command: sudo linux audit system. Linux then performed a security assessment of the operating system and generated a warning under the test PKGS 7392. As shown on the screen, the status is warning, indicating that one or more vulnerable or outdated packages were detected on the system. To mitigate this vulnerability, I performed the hardening process using the Ubuntu apt package management utility. The first step was updating the package repository information using the command sudo apt update. This command synchronizes the system with the official Ubuntu repositories and retrieves information about the latest available packages and security updates. Next, I upgraded the installed packages using sudo apt upgrade -y. This command installs the latest software versions and security patches to address vulnerabilities associated with outdated packages. After that, I remove unnecessary packages using sudo apt auto remove. This command removes packages that are no longer required by the operating system, helping to reduce the overall attack surface. Once the hardening process was completed, I performed a second security assessment using the same Linux command for verification. So I use sudo linux audit system command again, and the verification results show that the previous warning under test ID PKGS7392 is no longer present. The status has changed from warning to OK, indicating that the vulnerable packages have been successfully updated and the security issue has been resolved. In conclusion, the vulnerability assessment successfully identified outdated system packages, and the hardening process using package updates and security patches successfully mitigated the identified vulnerability. That's all from me. Thank you.
I will now explain the fifth vulnerability discovered during our Ubuntu 24.04 security assessment. So what is this vulnerability? The Ubuntu operating system uses firewall framework like IP tables and uncomplicated firewall (FW) to control incoming and outgoing network traffic. A secure firewall should block unauthorized access while allowing legitimate communication. However, in a default Ubuntu installation, the firewall framework is loaded but completely unconfigured. This means that the system has what we call an empty root set. Every network port and service running on the machine is fully exposed to the internet with no filtering, no access control, and no protection. Any attacker can scan the system, identify running service, and attempt to exploit them directly. Services like SSH, web server, are completely open to the public. The vulnerability is classified under CW693, protection mechanism failure, because the security control exists but is not actively protecting anything. Using the Linux security auditing tool, here's what our baseline can reveal. Linux generated a high priority warning fire 4512. The scanner confirmed that IP tables, the Linux firewall framework, is loaded into the kernel, but it checked for active role. It found none. This means the system has completely open network posture. Any background service running on any port, whether it's SSH on port 22, database on 3306, or web server on 80, is fully accessible to external network traffic. The risk impact affect all three security principles: confidentiality, integrity, and availability. Attackers can access sensitive service, exploit vulnerabilities, and launch DOS attacks. Mitigation involves configuring the uncomplicated firewall (UFW) to enforce a default deny policy. Let me explain each step. First, we set the default policy to deny all incoming traffic. This blocks anything not explicitly allowed. Outgoing traffic remains allowed for normal system functions like updates. Second, we explicitly allow SSH access, otherwise we would log ourselves out the server. After mitigation, we rerun the linear security audit. UFW status confirmed that the firewall was active with default deny incoming policy. Only SSH traffic on port 22 is permitted. Linux is no longer shows the fire 4512 warning. The test changed from warning to OK. The system network attack surface is now significantly reduced. Unauthorized incoming traffic is blocked at the kernel level before it can reach any service. Vulnerability 5 in Secure Firewall (RUSAT) has been successfully mitigated. This completes all 5 hardening procedures.